Tonight, as you settle into a comfortable position and let the noise of the day drift away, imagine looking up into a sky so wide and quiet that it seems endless. Above you, far beyond the reach of city lights or passing thoughts, the Milky Way stretches across the darkness like a soft river of stars. For thousands of years, people have looked at this gentle glow and wondered what secrets it carries. And now, in this quiet moment, you and I will take a slow, peaceful journey through its most soothing wonders. The Milky Way is our home in the universe, an enormous, spiraling world of starlight that moves with a patience beyond anything we feel here on Earth. Inside it, stars are born in clouds of glowing dust, drift through vast spiral arms, and eventually fade into gentle embers that continue to shine for ages. Some stars travel alone, while others stay together in clusters that move like families across the galaxy. And beyond what we can see with the naked eye lies a halo of ancient stars, cosmic remnants, and mysteries that have been drifting quietly since the beginning of time. Tonight, you'll explore 77 calming wonders of this magnificent galaxy, facts that won't overwhelm you, but instead will help your thoughts unwind as you fall deeper into rest. So breathe slowly, let your shoulders drop, and allow the Milky Way to unfold one peaceful fact at a time. Before we start, subscribe to my channel and hit the like button. Now plug in your headphones, relax, and dive into this amazing topic. If you could drift far above our galaxy, far beyond the reach of the sun, the planets, and every familiar star, you would see the Milky Way spread out beneath you like a soft, glowing swirl. It would look almost like a quiet river of light frozen in motion, its spiral arms curving gently outward as though painted by a patient hand. And even though the Milky Way is enormous, stretching hundreds of thousands of light-years across, there is a calmness to its shape. Nothing rushes in this grand design. Everything moves with a slow, steady grace that has held for billions of years. Just taking in that view, the soft glow, the delicate structure, the feeling of endless space can bring a sense of peace, as if the galaxy itself breathes at a pace meant to soothe the mind. One of the most interesting facts about the Milky Way is that it rotates as a whole, but in a way that feels almost effortless. The galaxy turns like a giant pinwheel, yet the motion is so smooth that, if you were floating inside it, you wouldn't sense any movement at all. Stars near the center complete their orbits faster because gravity is stronger there, while stars like our Sun, farther out, take hundreds of millions of years to make one trip around the galactic core. And yet this difference in speed doesn't tear the galaxy apart. Instead, all the stars and gas clouds settle into a pattern that keeps the spiral arms gently stretched out. It's a bit like watching dancers move at different speeds but still stay in perfect formation. Over countless ages, this peaceful rotation is what helped the Milky Way keep its beautiful shape. Another calming truth about our galaxy is that much of its glow comes from the combined light of billions of stars, many too faint to see individually. When their light blends together, it forms the soft hazy band we notice on clear nights. This glow isn't harsh or overpowering. It's subtle, delicate, and steady, almost like a warm memory stretched across the sky. If you've ever looked up and felt something shift inside you while seeing that faint ribbon of starlight, you were experiencing one of the gentlest features of our home galaxy. That quiet light is ancient. Much of it began its journey long before humans ever walked the Earth, traveling patiently across space until the moment it reached your eyes. The Milky Way's spiral arms are another source of calm beauty. They aren't solid structures, they're more like waves that move through the galaxy. Stars drift in and out of these arms over time, almost the way cars flow through traffic. But the pattern of the arms stays in place because of the slow, collective motion of everything inside the galaxy. These arms cradle the star-forming regions, vast clouds of gas and dust where new stars quietly begin their lives. As the galaxy rotates, these nurseries gently shift positions, glowing softly with newborn stars that light up the surrounding dust. The spiral arms aren't dramatic or chaotic. They're more like soft brushstrokes, steady and slightly blurred, giving the galaxy its signature calm elegance. Another fascinating detail is the way matter behaves inside the Milky Way. Stars, planets, dust, and gas all follow their own paths, but together they flow like a quiet cosmic river. This flow is guided by gravity, which acts like a gentle but persistent hand. It doesn't shove or pull suddenly. Instead, it encourages everything to settle into stable orbits, allowing stars to drift peacefully through space without colliding or losing their way. Even the clouds of gas that move between stars follow smooth paths, influenced by the same steady pull. Over billions of years, this flowing motion has shaped the galaxy's form, creating patterns that hold their beauty no matter how closely you look. Another calming fact is that the Milky Way is filled with far more space than matter. Stars are so spread out that if our sun were the size of a basketball, the nearest star would be several thousand miles away. That means the galaxy, large as it is, feels open and spacious. There's room for everything to move without crowding. This openness is part of what allows the galaxy to remain stable. The stars don't jostle one another. They drift quietly, each following its own orbit, like boats on a wide and tranquil ocean. When you imagine the Milky Way as a place of empty space rather than crowded stars, it begins to feel even more peaceful, almost like the galaxy is built from stillness more than anything else. As you look closer at the Milky Way structure, you'll find that it isn't just a flat spiral. It has a gentle thickness to it, with stars and dust rising above and below the main disk. This creates a soft, layered shape that looks almost like a glowing cloud. Most of the stars remain close to the central plane, but some drift farther away, creating a quiet halo effect. This vertical structure adds to the galaxy's beauty, making it appear rounded and full, not sharp or rigid. It gives the impression of a living, breathing system, one that has aged gracefully over billions of years, settling into its form the way a tree settles into its branches. One more soothing fact about the Milky Way is that our sun is just one of hundreds of billions of stars moving through this enormous structure. And yet, despite the number of stars, the galaxy remains calm. The sun drifts along a gentle path, taking about 230 million years to complete one orbit. During that time, entire species rise and fall on Earth, continents shift, climates change, and yet the sun's journey through the galaxy remains steady. This slow motion reminds us how small our individual worries can feel when placed against the backdrop of cosmic time. Everything moves at a pace so gentle, so measured, that you can almost feel your own breathing slow as you imagine it. As all these pieces come together, the spiral arms, the glowing band of stars, the open space between them, the slow rotation, the quiet halo, and the gentle pull of gravity, a picture begins to form of a galaxy that is both grand and peaceful. The Milky Way isn't a place of chaos. It's a place of balance, shaped by slow forces that give it structure without ever breaking its calm. Every star, including our sun, is part of this serene choreography. And as we let our thoughts rest in that image, the quiet swirl of starlight, the flowing movement of matter, the comforting rhythm of a galaxy that never rushes, we naturally drift toward the next part of our journey, into the spiral arms themselves, where stars are born, drift, and shine in the soft glow of the Milky Way's gentle patterns. If you were able to drift just above one of the Milky Way's spiral arms and look down with a quiet, unhurried gaze, you would see that these long, sweeping curves are not solid structures at all. They are more like gentle waves moving through the galaxy, waves made of stars, gas, and dust, each flowing in its own slow rhythm. The arms look permanent in pictures, but in reality, they shift over millions of years, forming patterns that are soft, flexible, and always changing in small, delicate ways. This makes the galaxy feel alive, as if it breathes in cycles so large and peaceful that we can only sense them by imagining the passage of deep time. One of the most calming facts about these spiral arms is that they move differently than the stars within them. The arms drift through the galaxy like slow-moving traffic patterns, while the stars themselves flow in and out of the arms on their own steady orbits. This means that a star like our Sun is not fixed in any single arm forever. Over hundreds of millions of years, it gently migrates, sometimes passing through brighter regions where new stars are forming, and other times gliding through quieter stretches filled with older, cooler stars. This migration is smooth and gradual, guided by the overall gravity of the galaxy. Nothing abrupt, nothing chaotic, just the quiet motion of countless stars sliding through these long, spiral lanes. Another soothing detail is how the spiral arms act as gathering places for star formation. As the arms move, they gently compress the gas and dust that float through the galaxy. This compression isn't forceful or violent, it's more like a slow squeeze, just enough pressure to help clouds collapse and form new stars. Because of this, the arms glow with clusters of young, bright stars that give the Milky Way its distinctive sparkle. These shining patches are often surrounded by soft, pinkish clouds that mark areas where stars are still being born. In these nurseries, the youngest stars flicker into existence, wrapped in warm light and drifting dust, their glow adding tiny sparks of life to the arms. Another interesting fact is that not all spiral arms are the same. Some are thick and bright, filled with both young and old stars, while others are thin and faint, more like wispy trails of starlight etched across the galaxy. These differences form naturally based on how gas and matter move within the galaxy's gravitational field. The Milky Way has a few major arms and several smaller ones, giving it a layered, textured look, like a soft spiral shell or a calm whirlpool of light. Even though the arms change shape slowly over time, they hold a gentle harmony that makes the galaxy recognizable even across millions of years. The Orion arm, where our solar system rests, is one of these smaller arms. It's not as large or grand as the major arms, but it's peaceful and full of interesting sights. Here, stars are spaced comfortably apart, giving our Sun and its planets a quiet region to drift through. We're not in a crowded or chaotic part of the galaxy. Instead, we exist in a calm neighborhood, in a cozy little lane between larger streams of starlight. This position has helped life on Earth thrive, giving us a stable environment with fewer disruptive influences from massive star clusters or regions of intense energy. Our home in the galaxy isn't dramatic. It's gentle, predictable, and steady. A soothing fact about the spiral arms is how slowly they turn. For all their size and beauty, they rotate at a pace so calm that even if you could watch them for a lifetime, you wouldn't notice any change. They need hundreds of millions of years to complete a full turn. These arms don't hurry or rush, they flow. And in that flow, they carry stars, gas clouds, and the seeds of future solar systems along peaceful, unbroken paths. This slow rhythm is one of the reasons the galaxy feels so timeless, like a quiet will turning somewhere far beyond the noise of everyday life. Another calming truth is that the spiral arms are full of dust, tiny particles floating and drifting through space. This dust softens starlight, creating the hazy appearance of the galaxy when seen from Earth. It also adds texture to the arms, making them look almost like long, glowing clouds rather than sharp structures. This dust is not just beautiful, it is essential. It provides the raw material for new stars and planets, recycling itself from older stars that have faded and released their matter back into the galaxy. In this way, the spiral arms become places of renewal, soft regions where the past and future blend together in cycles that feel natural and peaceful. What ties all of this together is the sense of motion that exists throughout the arms. Stars drift through them. Gas flows along their curves. Young stars ignite and old stars fade. Dust gathers, settles, and drifts again. Everything in the spiral arms moves, but at a pace so measured and smooth that the entire structure seems to rest in place. The arms give the galaxy its familiar shape, but they do so gently, as if guiding the stars rather than controlling them. This gentle drift leads naturally toward the regions where star formation happens most intensely, where clouds thicken, light glows softly through dust, and new stars quietly prepare to join the galaxy's long, calm dance. As we picture these spiral arms arching across the Milky Way, glowing faintly with newborn starlight and drifting dust, our thoughts naturally begin to slip into these bright nurseries themselves, the places where stars take shape inside quiet clouds, beginning the soft cycle of light that fills the galaxy with warmth and wonder. If you could drift quietly into one of the Milky Way's great star-forming regions, you wouldn't see bright fireworks or sudden bursts of light. Instead, you'd find yourself surrounded by enormous clouds of gas and dust, soft, dark shapes stretching across space like gentle shadows. These clouds, called stellar nurseries, are some of the quietest places in the galaxy. In their stillness, young stars begin forming slowly and naturally, almost the way seeds sprout beneath warm soil. The process takes millions of years, but there is something soothing about it, something steady and patient. It reminds us that even the brightest stars begin in darkness, gathering themselves little by little until they're ready to shine. Inside these nurseries, the gas and dust are held together by gravity, which acts with a calm and constant pull. Over time, certain pockets become denser than others. These denser regions start to sink inward, pressing together more tightly. What's fascinating is that this collapse doesn't happen all at once. It's gentle, like watching clouds thicken in slow motion. As the material compresses, it warms, and that warmth becomes the early heartbeat of a forming star. Even though this warmth is faint at first, it signals the beginning of something new, a small glow deep inside a cloud that has been drifting quietly through the galaxy for ages. One of the most interesting facts about these nurseries is how large they are. Some stretch hundreds of light years across, big enough to hold thousands of future stars. Yet even inside these enormous clouds, the forming stars remain far apart. There's plenty of space for each to grow without disturbing the others. The darkness of the dust hides them from view, shielding their earliest moments until they grow bright enough to pierce through the cloud. From the outside, these regions often look like soft, dark patches in the Milky Way, places where starlight seems to fade. But hidden within them is the quiet glow of new life slowly unfolding. Another calming truth is that young stars form in groups. Rarely does a single star take shape entirely on its own. Instead, dozens or hundreds may be forming simultaneously, each one cradled in its own little pocket of gas and dust. These young stars are called protostars, and in their earliest stages, they shine only faintly. They are warm, not bright. Their glow is soft and steady, more like a candle than a beacon. As they continue gathering material from their surroundings, they grow hotter and begin spinning more quickly. This spin helps shape disks of dust around them, dust that may one day form planets, moons, and other quiet companions. The idea that planets may begin forming while a star is still in its earliest stages adds another layer of wonder to these nurseries. Everything evolves together, gently and gradually. One of the most soothing features of a stellar nursery is the way light filters through the dust. The smallest dust grains scatter light in soft, muted colors, often giving these clouds a pink or reddish glow when viewed through telescopes. That gentle tint comes from the presence of hydrogen gas, which lights up when newborn stars shine on it. Even though these stars can't yet be seen directly, their growing warmth illuminates the surrounding gas like a soft lantern glowing behind a thin curtain. These colors weave through the cloud with a dreamy quality, showing us where new stars are quietly preparing to emerge. It's a reminder that beauty often forms long before we can see it clearly. Another fascinating fact is that stellar nurseries can last for millions of years, but they don't stay intact forever. As young stars grow and brighten, their light and winds begin to push away the dust that once hid them. Slowly, the nursery opens, revealing clusters of newborn stars shining together for the first time. These clusters are often loose and gentle in appearance, their stars still drifting near one another as they start their journeys through the galaxy. Some will stay together for a long time, held by gravity, while others will eventually drift apart and wander on their own paths. But their shared origin, the calm cradle of the nursery, remains part of their story forever. As these stars mature, they take on different personalities. Some burn hot and bright, shining with blue or white light that cuts through the dust around them. Others glow softly in yellow or red tones, their warmth quiet and steady. Most stars, including ones like our Sun, settle into a long, stable phase where they burn hydrogen gently for billions of years. This stage is peaceful and predictable, and it makes up the majority of a star's life. During this period, the star is calm, balanced, and steady, a comforting presence in the galaxy's vastness. The energy it releases supports any planets that may have formed around it, offering light and warmth in a rhythm that rarely changes. What makes this transition from a hidden protostar to a mature star so calming to imagine is how natural each step is. Nothing about the process is rushed. Nothing is forced. The star gathers itself, finds balance, and eventually settles into a quiet pattern that will last for an incredibly long time. Even the largest, brightest stars move through their lives with a kind of cosmic patience, unfolding in stages that take millions or billions of years. There is a peaceful wisdom in that longevity, a reminder that growth doesn't have to be fast to be meaningful. Eventually, the dust that once sheltered the star disperses, either blown away by the young star's light or pulled into forming planets. The nursery thins out, leaving the new cluster of stars drifting together like a family stepping into open space. The brightest stars now illuminate the region, casting light on whatever remains of the cloud. Over time, the cluster may move out of the spiral arm where it was born, beginning a long journey around the galaxy. Some stars will travel together for ages, while others will slowly drift apart, becoming isolated wanderers in the Milky Way. But whether together or alone, each carries the memory of its birthplace, a quiet, shadowed nursery where it first began to shine. This gentle process, clouds collapsing, stars warming, dust glowing, clusters emerging, is one of the most beautiful rhythms in the galaxy. It's the cycle that fills the Milky Way with light, generation after generation. It creates the stars that shape spiral arms, the stars that warm planets, and the stars that eventually become part of the galaxy's soft glow. When you think of the Milky Way stretching across the night sky, shimmering softly from horizon to horizon, you're seeing the combined light of these stars at every stage of life. Some are new. Some are old. Some are still hidden in nurseries, gathering strength for the day they will join the galaxy's gentle radiance. And as we leave these peaceful nurseries behind and follow the young stars as they emerge into open space, our journey naturally turns toward the next part of their story, the long, steady life of the stars that now shine clearly across the Milky Way, illuminating the galaxy's arms with calm and timeless light. When a young star finally settles into the long and steady rhythm that will define most of its life, it begins a journey that is both simple and remarkable. For millions or even billions of years, a star shines with a calm, dependable glow, holding itself together through a careful balance of inward pull and outward warmth. From a distance, this balance looks effortless. The star appears peaceful, almost unchanging, like a small lantern suspended in space. And in many ways, that appearance is true. Most stars spend the majority of their lives in this gentle, middle stage, where their light is steady and their energy is controlled, creating environments that can remain stable for unimaginable stretches of time. A comforting fact about these mature stars is how reliable they are. A star like our Sun has been shining for more than 4.5 billion years, and it will continue shining just as steadily for billions more. The warmth it provides doesn't flicker or surge in dramatic ways. It stays within a narrow range that has supported life on Earth for countless generations. This consistency is one of the reasons life can grow and thrive on planets that orbit stable stars. The gentle light of a sun-like star creates a sense of cosmic security, a reminder that in the grand scale of the galaxy, some things remain strong and steady for eons. As stars age, they begin to change very slowly, and these changes are just as calm as their younger years. One of the most soothing transformations happens when a star begins to run low on fuel in its core. Instead of collapsing suddenly or erupting without warning, the star gradually expands. It becomes a red giant, a large glowing sphere with a softer, warmer color. Red giants shine with a gentle reddish light, their surfaces cooler than when they were younger. They grow enormous, sometimes large enough to engulf the space where their inner planets once orbited. But despite their size, they glow with a peaceful presence, appearing almost like cosmic embers drifting through space. These red giants play an important role in the galaxy. One interesting fact is that they create many of the heavier elements found throughout the Milky Way. As they evolve, their internal layers begin producing elements like carbon and oxygen, which later become part of new stars, planets, and even living things. When a red giant eventually releases its outer layers, it does so gently, sending out gas and dust that will one day become part of something new. This quiet recycling process helps enrich the galaxy with the materials needed for future generations of stars and worlds. In this way, even a dying star contributes to the calm, ongoing flow of cosmic life. While many stars become red giants, others take a different path, especially the smaller ones. The smallest stars in the galaxy, known as red dwarfs, burn their fuel so slowly that they can live for trillions of years, far longer than the universe has existed so far. This extraordinary lifespan is one of the most soothing facts in astronomy. These tiny stars glow with a faint, steady light, creating a gentle presence in the galaxy that will continue long after every sun-like star has burned out. If you were to orbit a red dwarf, you would see a sky lit not by a brilliant sun but by a quiet, cool star that shines with endurance rather than intensity. The long, stable lives of red dwarfs are a reminder that longevity often comes from calmness, patience, and slow, steady energy. At the opposite end of the spectrum are stars larger and hotter than our Sun. These stars live fast, burning brightly and intensely for only a few million years before exhausting their fuel. Even so, their presence in the galaxy is not chaotic. Their brightness helps light up their surroundings, illuminating dust clouds and creating beautiful glowing regions. Their energy helps trigger the formation of new stars by compressing nearby gas clouds. In this way, even the most powerful stars contribute gently to the galaxy's ongoing cycle. Their influence shapes the environment for future generations of stars, demonstrating that even intense cosmic forces can play a peaceful role in the larger pattern of the Milky Way. Another calming fact about stars is that many of them don't travel through the galaxy alone. They are born in clusters, and those clusters often remain together for long periods of time. Imagine hundreds or even thousands of stars moving together across the Milky Way, all formed from the same cloud of gas and dust. These star clusters drift like families, their stars shining side by side as they orbit the galactic center. Some clusters stay tightly grouped, while others gradually spread out, loosening their bonds over millions of years. Either way, the connection between these stars remains part of their identity. They share the same age, the same birthplace, and often the same gentle motion through the galaxy. As clusters drift farther from their stellar nursery, the stars begin to spread out, but the core group often stays visible as a soft gathering of lights. One of the most famous examples is the Pleiades, a cluster of young stars that can be seen from Earth as a small, shimmering group in the night sky. Even from such a distance, the cluster carries a feeling of warmth and unity. The stars are bound by a shared history, moving as one across the dark, quiet background of space. Some clusters, known as globular clusters, are even more tightly packed, containing hundreds of thousands of stars all held together by gravity. These clusters orbit the Milky Way like ancient companions, their stars older than most of the galaxy itself. Despite their age, they maintain a sense of harmony, their stars moving slowly and predictably within the cluster. They seem almost like cosmic villages, small, crowded communities glowing softly in the darkness, each one holding stories that stretch back to the earliest days of the universe. What ties all of these stages of stellar life together is the idea of cycles. Stars are born in calm, shadowed nurseries. They grow into stable suns that shine with dependable light. They expand into gentle red giants or drift quietly as cool dwarfs. Some shed their outer layers softly, contributing to future stars. Others explode in magnificent events that seed the galaxy with heavy elements. And many remain in clusters, traveling together like old friends on a long, peaceful journey. Each stage is part of a larger rhythm, one that unfolds slowly, gracefully, and without interruption. As we follow the lives of these stars from their earliest sparks to their mature glow, and as we watch them gather into clusters that drift across the Milky Way, a picture begins to form of a galaxy shaped not by chaos, but by patterns of calm and continuity. And from here, our journey naturally leads to the next chapter, the relationships these clusters form as they drift together through the Milky Way, sharing their light and shaping the galaxy's gentle structure as they move across the starlit sky. If you could drift quietly through the Milky Way and approach one of its many star clusters, the first thing you might notice is how peaceful they look. Dozens, hundreds, or sometimes hundreds of thousands of stars glow together in a shared space, like a small island of light floating in the dark. Star clusters form when groups of stars are born from the same cloud of gas and dust, and because they share this beginning, they move through the galaxy as if they're part of a slow, gentle caravan. Even though each star lives its own life, the cluster holds them together for a long time, giving the impression of a quiet family traveling across the Milky Way at a calm and steady pace. One comforting fact about these clusters is that their stars are usually close in age. They begin shining at roughly the same time, which gives each cluster a sense of harmony. Young clusters, filled with bright blue and white stars, look lively and fresh, their light intense but still soft from a distance. Older clusters glow more faintly, with redder, cooler stars that have settled into their long, steady lifespans. Regardless of age, the stars within a cluster share a story, a shared birthplace, a shared starting point, and this connection gives the cluster its peaceful character. There's something soothing about knowing that in the vast chaos of the universe, these small communities of stars remain together for so long. Another interesting truth is that there are two main types of clusters, each with its own gentle personality. Open clusters are loose and delicate, containing a few dozen or a few hundred stars. They're often found in the spiral arms of the Milky Way, where star formation is still active. These clusters gradually spread apart over time, releasing their stars into the galaxy like seeds carried by a slow-moving breeze. One familiar example is the Pleiades, a beautiful little cluster that looks like a soft shimmer of light in the night sky. Its stars are young, blue, and full of energy, yet the cluster as a whole feels calm and comforting, a small family glowing together while drifting through space. Globular clusters, on the other hand, are dense and ancient. They contain tens of thousands or even hundreds of thousands of stars packed closely together in a perfect sphere. If you could stand inside one, imagining for a moment that such a thing were possible, you would see more stars around you than you could count, each one glowing warmly in the surrounding darkness. These clusters orbit the Milky Way like quiet companions, moving far above and below the main spiral arms. Because their stars are so old, globular clusters act as time capsules, preserving memories from the earliest days of the galaxy. Their steady orbits and deep history give them a wise, almost grandfatherly presence among the stars. One of the most soothing facts about star clusters is how gracefully they move. They don't speed through the galaxy with reckless energy. Instead, they follow long, sweeping paths shaped by the Milky Way's gravity. Their motion is slow enough that even over many human lifetimes, their positions hardly change. It takes millions of years for a cluster to drift into a noticeably different region of the galaxy. This slow, predictable motion creates a sense of cosmic stability. In a universe that can sometimes feel overwhelming in its size, star clusters offer a reminder that many parts of it move with calm intention, not in randomness or haste. As clusters travel, they gradually interact with the galaxy around them. Open clusters, being loosely bound, often lose their stars over time. A passing cloud of gas, a gravitational nudge from another cluster, or simply the natural spreading of stars along their orbits can cause members to drift away. But this drift isn't violent or dramatic. It's slow, gentle, almost like watching petals fall from a flower in a soft breeze. Those stars go on to join the wider population of the Milky Way, carrying with them the quiet memory of where they came from. Over billions of years, many of the stars around our Sun may have started their lives in clusters that dissolved long ago. Globular clusters behave differently. Because their stars are so tightly packed together, they can remain intact for billions of years. These clusters orbit the galaxy's outer regions in enormous loops, moving like serene guardians around the Milky Way. Their stability helps astronomers understand the shape and age of our galaxy, because globular clusters preserve information that newer stars may have lost. They are steady markers in a universe where so much is constantly changing. Whenever the Milky Way shifts or evolves, these clusters continue their slow, reliable paths, unbothered by the galaxy's internal motions. Another interesting fact is that star clusters help shape the galaxy's structure. As young clusters form and eventually release their stars, those stars contribute to the spiral arms and add to the galaxy's soft glow. The distribution of clusters, even after they disperse, helps create patterns in the Milky Way's disk. Meanwhile, globular clusters provide a kind of scaffolding in the halo surrounding the galaxy, marking its outer boundaries and offering clues about how the Milky Way formed in the first place. In this way, clusters are more than just families of stars. They're building blocks of the galaxy itself, guiding its evolution with quiet persistence. One more comforting truth about clusters is that they help us understand where our own Sun may have come from. Many scientists believe the Sun was born in an open cluster long ago, surrounded by sibling stars that drifted away over time. If that is true, our Sun once glowed among dozens or hundreds of other young stars, sharing light and warmth before eventually moving into a quieter region of the galaxy. The idea that the Sun had siblings, stars born from the same cloud, adds a tender feeling to our place in the galaxy. Those siblings, now scattered across the Milky Way, may still shine softly somewhere far away, carrying the same ancient fingerprint of their shared birth. Star clusters, with their slow drifting motion and their sense of unity, offer one of the most peaceful perspectives in astronomy. They remind us that even in a universe filled with powerful forces, gentle patterns emerge. Stars gather, shine together, and then slowly move apart, each following its own path while contributing to something larger than itself. These clusters move like small communities, connected by origin and by the long arcs of their orbits, shaping the Milky Way in ways that unfold across ages far longer than human history. And as these clusters glide through the galaxy, some dissolving softly into the spiral arms, others circling the Milky Way in ancient loops, they guide our attention naturally toward the larger structure of the galaxy itself. They point us inward, toward the shining center where stars rotate in tighter orbits, and outward, toward the edges where the halo stretches into deep space. With their quiet influence, they lead us gently into the next part of our journey, toward understanding the Milky Way from the inside out and the role our own Sun plays within this calm, drifting sea of stars. When you imagine the Milky Way as a great spiral drifting through space, it's easy to picture it from the outside, broad arms curling outward, glowing bands of starlight stretching across the darkness. But our experience is very different. We live inside the galaxy, carried quietly on a small arm called the Orion Arm, tucked between two of the Milky Way's larger, brighter spiral arms. From this position, we can't see the galaxy's shape directly. Instead, we experience it the way someone inside a forest might experience the woods around them. One tree at a time, one patch of sky at a time, never quite seeing the full picture, but feeling its presence all around. This inside-out view gives us a unique and gentle perspective. It reminds us that even though the galaxy is enormous, our small place within it is surprisingly calm and stable. One of the most comforting facts about our position in the Milky Way is that the Orion Arm is a quiet neighborhood. It's not densely packed with stars, and it's far from the chaotic activity near the galactic center. Instead, our region is open, spacious, and peaceful. The stars around us are spread out enough that collisions and disruptions are extremely rare. This calm has allowed our Sun and its planets to follow the same steady path for billions of years. If Earth had formed closer to the center of the galaxy, where stars crowd together tightly and radiation is intense, life might never have had the chance to settle and grow. But here, in this gentle lane of starlight, we drift with a sense of cosmic safety. Another soothing truth is that our solar system orbits the center of the Milky Way with remarkable consistency. Even though we are moving at nearly 500,000 miles per hour, we never feel this motion. Everything around us, the Sun, the planets, the Moon, and even nearby stars, moves together like a flock of birds gliding through the air. It takes about 230 million years for our solar system to complete a single orbit around the galaxy's center. During that time, continents rise and fall, species come and go, and civilizations bloom and fade. Yet the galaxy's pull remains steady, carrying us along a smooth, predictable path that has been followed for as long as the Sun has existed. As we orbit, we sometimes pass through different environments within the Milky Way. Some regions contain denser clouds of gas and dust, while others are more open and filled with older stars. One interesting fact is that the Sun is currently located between two major arms, the Perseus Arm and the Sagittarius Arm, which means we enjoy a relatively quiet corridor with less gas and fewer star-forming regions. This position gives us a clear view of parts of the galaxy while also shielding us from areas where radiation and energy levels are much higher. It's almost as if our solar system rests in a peaceful clearing within a vast, luminous forest. Looking outward from Earth, the Milky Way appears as a faint band stretching across the night sky. This band is actually the disk of our galaxy, seen from the inside. All those countless stars blend together into a soft glow because of the dust that lies between us and the deeper regions of the galaxy. That dust dims and scatters the light, creating the hazy appearance we're familiar with. This interstellar dust gives our inside-out view its charm. It softens the starlight, making the galaxy appear gentle and dreamlike rather than harsh or overwhelming. Without that dust, the night sky would look much brighter, but it would lose some of its calming, quiet beauty. As we drift around the galaxy, the Sun carries us slightly above and below the galactic plane in a slow, rhythmic motion. You can imagine it as a gentle bobbing, like a boat rising and falling on calm ocean waves. This vertical movement happens over tens of millions of years and doesn't disturb the solar system in any noticeable way. It simply adds a peaceful, rocking motion to our long journey, reminding us once again that the forces shaping our path unfold across timescales far longer than any human lifetime. Another fascinating fact is that even though we orbit the center of the galaxy, we are nowhere near the actual middle. The galactic center lies about 27,000 light-years away, so far that even the fastest spacecraft we've ever built would need thousands of lifetimes to approach it. From our distance, the center appears as a dense, glowing region hidden behind thick clouds of dust. That dust blocks visible light, but infrared and radio waves can slip through, allowing astronomers to peer inside. What they find there is a place filled with activity, stars orbiting tightly, clouds gathering and collapsing, and at the very heart, a massive object exerting a quiet but powerful influence. Even from our peaceful position in the Orion Arm, we feel the pull of this central mass. It helps guide our orbit and the motion of countless stars like ours. The center's gravity holds the entire galaxy together, shaping the Milky Way's rotation and giving its spiral arms their graceful structure. Most of the time, we barely think about this central influence. But every star in the galaxy is connected to it, and every orbit, including the Sun's, is part of a larger pattern set into motion billions of years ago. The idea that we're all moving together around a shared center brings a feeling of belonging, as though we're part of a vast, quiet dance that unfolds across time. As we continue imagining our solar system drifting through space, it becomes easier to feel the gentle relationships that shape our cosmic home. There is the pull of the galactic center, steady and constant. There is the calm movement of nearby stars, many of which share similar paths. There is the soft glow of distant spiral arms, which we can sometimes glimpse between clouds of dust. And there is the awareness that everything, every star, every cluster, every drifting cloud, is connected through gravity into a grand, harmonious structure. From here, the next natural step in our journey is to look toward the center itself, to explore the region where stars move in tight circles and where a powerful, mysterious presence rests at the core of the Milky Way. If you could slowly drift toward the center of the Milky Way, the journey would feel like moving into a brighter and more crowded neighborhood of stars. The quiet, open spaces of the Orion Arm would gradually give way to thicker clouds of light, where stars sit closer together and glow with a steady brilliance. It might look busy from a distance, but even here, in one of the most active regions of our galaxy, there is a remarkable sense of order. Everything moves according to gentle, predictable paths shaped by an unseen but powerful presence at the heart of it all. That presence is the Milky Way's central black hole, a massive object whose gravity guides the rhythms of the galaxy in a calm and steady way. One of the most interesting facts about this black hole is that, despite its intimidating reputation, it is extremely quiet. It isn't constantly pulling stars inward or swallowing everything around it. Instead, it sits peacefully at the galactic center, influencing the orbits of nearby stars without disturbing their natural flow. Its gravity is strong, yes, but it's also stable. It keeps the core of the galaxy organized, acting like an anchor that holds the entire structure together. Without it, the central regions would not rotate as smoothly as they do. The black hole's presence brings order, not chaos, and that alone surprises many people. Another calming truth is that even though this black hole is 4 million times the mass of our Sun, you could drift near it, if you stayed at a safe distance, and feel no sudden pull. Gravity weakens with distance, and the inner regions of the Milky Way, though shaped by this enormous object, are not places of violent tugging or unpredictable motion. Stars orbit calmly around the center, following long, elegant paths carved out by gravity over billions of years. If you could watch these orbits unfold in real time, you would see stars completing wide loops, their motions smooth and controlled, almost like lanterns floating in slow circles around a fire. A fascinating fact about the stars near the galactic core is how closely some of them orbit the black hole. A few stars swing around it in paths that bring them astonishingly near, completing their orbits in just a handful of years. These stars move quickly, much faster than the Sun, but their speed isn't frantic. It's what naturally results from the graceful balance between their motion and the black hole's gravity. When scientists track these fast-moving stars, they see no signs of chaos or destruction. Instead, they observe a cluster of stars following regular, predictable loops that show just how peacefully a galaxy can coexist with a black hole at its center. As you imagine drifting even closer, the brightness of the core becomes more noticeable. Dust clouds swirl throughout the region, glowing softly as they reflect and filter starlight. The central bulge, a thick, rounded gathering of older stars, shines like a warm lantern in the heart of the galaxy. Many of these stars are ancient, some among the oldest in the Milky Way. Their long lifespans have given the core a gentle, steady glow, a soft golden radiance that stands in contrast to the cooler, bluer light seen in younger regions of the galaxy. The bulge itself has a smoothness to it, shaped by countless stars moving in calm, overlapping paths that create a sense of roundness when viewed from afar. Another soothing fact is that much of the galactic center is hidden from our eyes by thick dust. This dust absorbs visible light, creating a veil that softens the brightness reaching us. It's why, when you look toward the center of the Milky Way from Earth, You see a hazy band rather than the full intensity of its glow. But even this obscured view has its charm. The dust acts like a natural filter, giving the galaxy a calm, muted appearance that is perfect for nighttime viewing. Behind that gentle haze, stars are moving together in harmony, unaware of the soft curtain that lies between them and our distant vantage point. The center of the Milky Way is also home to remarkable structures made of gas and dust. Long filaments weave through the region like delicate threads, some stretched by magnetic fields, others pulled gently by gravity. These filaments glow faintly in infrared light, tracing patterns that highlight the quiet but persistent forces at work. Though these structures look intricate, they remain stable for long periods, drifting slowly as they follow the gravitational contours of the core. Their presence adds texture to the region, making it feel less like a single bright mass and more like a layered tapestry woven from starlight and shadow. As we take in these scenes, another calming truth becomes clear. The core of the Milky Way is not a place of constant destruction. Yes, stars here are packed more closely together, and yes, the central black hole sits at the heart of it all. But more often than not, stars simply orbit, clouds drift, and gravity shapes their paths with gentle consistency. The black hole grows only when material wanders too close, and such events are rare. Most of the time, it is simply a dark anchor in a bright sea of stars, exerting influence without drawing attention to itself. This quiet existence stands in contrast to how black holes are often imagined. Many people picture them as cosmic vacuums, swallowing everything nearby. But the one at the Milky Way's center behaves more like a steady weight that keeps the galaxy balanced. It doesn't drag stars inward, it guides their motion. It doesn't radiate chaos, it maintains order. The stars closest to it reveal this clearly. They move in predictable ellipses, showing us that gravity, when left undisturbed, creates patterns more peaceful than frightening. Eventually, as we pull our gaze outward again from the galactic core, the bright central region begins to soften, and the broader shape of the Milky Way becomes clearer in our imagination. The glowing bulge transitions back into the spiral arms, the dust lanes stretch outward like quiet pathways, and the gentle flow of stars guides us naturally from the center into the surrounding galaxy. As we think about what lies beyond the bright bulge, beyond the thick crowds of ancient stars and the quiet black hole, we begin to sense the larger structure of the Milky Way expanding around us. And with that widening view, we're drawn to the parts of the galaxy that extend far out from the disk, into regions filled with faint, ancient light and drifting remnants of earlier eras. Our journey now moves outward, toward the vast halo that surrounds the Milky Way, where old stars and quiet mysteries float in the deep stillness beyond the spiral arms. If you could rise slowly above the bright disk of the Milky Way and drift farther and farther into the quiet darkness surrounding it, you'd begin to notice something surprising. The galaxy doesn't simply end where the spiral arms fade. Instead, it is wrapped in a vast, faint halo made of ancient stars, drifting star clusters, and wisps of matter so thin and quiet that you might pass right through without realizing anything is there. This halo stretches far beyond the visible edges of the Milky Way, so far that, compared to it, the entire glowing disk looks small and delicate, like a lantern surrounded by a soft, invisible atmosphere. Its presence is subtle, almost ghost-like, but it holds some of the oldest and most intriguing parts of our galaxy. One of the most calming facts about this halo is how quiet it is. Inside the disk of the Milky Way, stars move in familiar circular patterns, guided by the rotation of the galaxy. But the halo has no such organized motion. The stars here drift in long, slow, looping paths, like feathers carried by a gentle breeze. Many of these stars are incredibly old, dating back to the early days of the universe. They shine faintly with a soft, steady glow, having burned calmly for billions of years. Their age alone gives this region a sense of deep stillness, as if time moves differently here, more slowly, more thoughtfully, than in the busy spiral arms below. Another interesting truth is that the halo contains globular clusters, those tightly packed families of stars that orbit the Milky Way like ancient satellites. These clusters are some of the most beautiful structures in the galaxy, dense spheres glowing with hundreds of thousands of old stars. When seen from afar, each cluster looks like a shimmering bead of light, floating alone in the vast halo. These clusters have remained intact for billions of years, surviving the galaxy's slow motions and holding their stars close through long ages. Their stability adds to the halo's peaceful nature. They act like quiet guardians, marking the outer boundaries of the Milky Way with their soft golden glow. Beyond stars and clusters, the halo is also filled with remnants of galaxies that the Milky Way absorbed long ago. Over billions of years, smaller galaxies wandered too close and were gently pulled apart by gravity. Their stars became part of the halo, stretching out into long, delicate streams that wind around the Milky Way like faint ribbons. These streams are almost invisible to the human eye, but they can be detected through careful measurements of star positions. They tell a quiet story, one of slow change, patient blending, and the natural way galaxies grow by gathering material over long stretches of time. Even these remnants move peacefully, drifting along paths shaped by ancient events. A fascinating fact is that the halo contains far more space than the rest of the galaxy. It is so open, so vast, that the stars within it are separated by enormous distances. If the disk of the Milky Way feels like a neighborhood, then the halo feels like the countryside, broad, quiet, and lightly populated. This gives the halo a sense of serenity that is hard to find in the busier parts of the galaxy. The stars here rarely interact. They move alone, following paths that can take hundreds of millions of years to complete. Yet they all remain part of the Milky Way's extended family, connected through gravity to the galaxy's center even from great distances. Another calming truth is that the halo helps hold the Milky Way together. Much of the galaxy's hidden mass, the material we cannot see directly, exists in and around this halo. It acts like an invisible framework that supports the spiral structure and keeps stars moving in their familiar orbits. Without the mass in this halo, the Milky Way would not rotate the way it does now. The spiral arms would loosen, and the stars would drift apart. Instead, the halo provides a slow, steady pull that maintains the galaxy's graceful shape. It is a reminder that some of the most important influences in the universe are the ones we cannot see with our eyes. The halo is also a window into the galaxy's earliest days. Many of the stars here formed when the Milky Way was young, long before the spiral arms had fully taken shape. These stars contain fewer heavy elements than newer stars, telling us they were born in a time when the universe was much simpler. Their chemistry reflects the early stages of star formation, allowing astronomers to understand how galaxies grew from the quiet, ancient clouds that filled space after the Big Bang. These old stars are like living fossils, gentle, unchanging, and carrying the memory of a time that no longer exists. Another soothing fact is how softly the halo blends into the broader cosmos around it. There is no clear boundary where the halo stops and intergalactic space begins. Instead, the region becomes gradually sparser, with stars drifting farther apart until they fade into the background of the universe. This soft transition gives the halo a natural, unforced feeling. It doesn't cut off sharply or end abruptly. It simply becomes one with the larger cosmic environment, much like the way a quiet shoreline merges with the open sea. As you imagine floating in this halo, surrounded by ancient stars and delicate streams of light, the Milky Way below you would appear as a soft glow stretching across the darkness. The galaxy wouldn't look chaotic or overpowering. It would look calm, rounded, and balanced, its spiral arms turning slowly beneath you. From this vantage point, you could sense the Milky Way as a whole, not just the neighborhood where we live. You'd feel its quiet structure, its steady motion, and the way all its parts, disk, bulge, halo, fit together in harmony. And as your gaze drifts outward, beyond the halo, you'd begin to notice faint smudges of light in the distance. Other galaxies, other realms of stars, each with its own calm rhythms and ancient history. The halo gently guides your attention from the Milky Way itself to the larger universe around it, inviting you to step even farther into the cosmic environment that surrounds our galaxy. If you could float just beyond the Milky Way's faint halo and let your eyes adjust to the darkness, you would begin to notice that our galaxy is not alone. All around it, scattered across the night like quiet neighbors living on distant hillsides, are other galaxies, some small and softly glowing, others large and majestic, each following its own slow rhythm through space. Even though they are far apart, these galaxies share gentle gravitational connections, subtle tugs and pulls that shape their paths over billions of years. The Milky Way drifts among them like a calm traveler surrounded by companions, each moving through the universe with patient, unhurried grace. One of the most comforting facts about our galactic neighborhood is the presence of the Magellanic Clouds, two nearby galaxies that accompany the Milky Way like old friends walking beside us. The Large Magellanic Cloud and the Small Magellanic Cloud move through space in wide loops, drifting around the Milky Way in a slow, steady dance. To the human eye, especially in the southern hemisphere, they appear as soft, cloud-like patches of light shimmering gently against the night sky. These galaxies are irregular in shape, filled with clusters of young stars and glowing nebulae, and they have been companions of the Milky Way for a very long time. Their presence adds warmth to the idea of a galaxy cluster, suggesting that even enormous structures can have relationships and connections that last across cosmic time. Another fascinating truth is that the Magellanic Clouds exchange material with the Milky Way. Long streams of gas extend between them, forming bridges of matter that arc quietly across space. These streams don't rush like rivers, they drift slowly, moving under the guidance of gravity. Over millions of years, some of this gas may help form new stars in the Milky Way's outer regions, adding small touches of light to the galaxy's soft glow. This gentle sharing of material is a reminder that galaxies, like living ecosystems, grow and change through subtle interactions with their surroundings. As you drift your attention a bit farther outward, you would begin to sense the presence of the Milky Way's larger companion, the Andromeda Galaxy. Andromeda is the closest large spiral galaxy to us, located more than 2 million light-years away. From our viewpoint on Earth, it appears as a faint, elongated smudge of light. You might not notice it at first unless the night is very dark and clear. But once you see it, it becomes unforgettable. Andromeda is larger than the Milky Way, stretching across space with sweeping spiral arms and a bright central core. And even though it's incredibly far away, its light reaches us every night, carrying the story of a galaxy that mirrors our own in shape and structure. One of the most soothing facts about Andromeda is that it is slowly moving toward the Milky Way. There's nothing alarming about this. The pace is extraordinarily slow, so slow that it will take more than 4 billion years before the two galaxies touch. Even when they do, the interaction won't resemble a violent crash. Stars are spaced so far apart that most will pass by one another without ever making contact. Instead, the two galaxies will drift together and blend, forming a larger, calmer galaxy over millions of years. This slow-motion dance teaches us something valuable. Even cosmic mergers, which sound dramatic on paper, unfold with a peacefulness that spans longer than the entire history of life on Earth. Andromeda and the Milky Way are not the only galaxies participating in this gentle choreography. The local group, the small cluster of galaxies that includes the Milky Way, is home to more than 50 galaxies of various shapes and sizes. Most of them are dwarf galaxies, quiet, faint, and modest, circling the Milky Way or Andromeda like small birds accompanying larger ones. These tiny galaxies follow their orbits with patient grace, slowly moving through space in patterns that have remained steady for billions of years. Some are gradually being drawn closer to the Milky Way, where they will eventually blend into the halo just like the remnants of earlier galaxies. This ongoing process is subtle and calm, another example of how the universe evolves through gentle steps rather than sudden leaps. One particularly interesting fact is that some of these dwarf galaxies form a kind of rotating plane around the Milky Way, almost like a thin disk of small companions circling the larger galaxy. This arrangement suggests a shared history. Perhaps these galaxies were once part of a single larger structure that slowly separated over time. Their motions, though faint and difficult to detect, add a layer of quiet complexity to the Milky Way's surroundings. They remind us that even the smallest galaxies have their place in the cosmic pattern, contributing to the slow shaping of the environment around them. As you move through this neighborhood in your mind, imagining the Milky Way, the Magellanic Clouds, Andromeda, and the many faint galaxies that drift alongside them, a picture begins to form of a community of galaxies connected by gravity and shared history. These connections stretch across millions of light-years, yet they operate with such gentleness that the galaxies feel more like peaceful companions than distant strangers. Their motions reveal the deeper structure of the universe, how galaxies gather into groups, how those groups connect into larger clusters, and how everything eventually forms part of the vast cosmic web. Another calming fact is that these interactions help shape each galaxy over time. When smaller galaxies pass near the Milky Way, their gravity can create gentle ripples in our spiral arms, encouraging new waves of star formation. When gas streams from one galaxy to another, it adds fresh material for new stars to grow. Even the future meeting between the Milky Way and Andromeda will likely lead to beautiful new star-forming regions, glowing softly with baby stars born from the merging gas. The evolution of galaxies is not just a story of movement, it's a story of renewal, connection, and gentle transformation. The more you picture these galaxies drifting through space together, the more peaceful the universe seems. None of these motions happen quickly. None of them are rushed. Everything unfolds in long, patient arcs, guided by gravity's steady hand. In this calm, interconnected environment, the Milky Way feels like just one voice in a quiet cosmic choir, a member of a group, not isolated but gently embraced by the galaxies around it. And as we drift even farther in imagination, letting our awareness widen beyond the local group, we begin to sense the larger structures these galaxies form, the filaments, clusters, and grand webs stretching across the universe. The quiet interactions between neighboring galaxies prepare us for this bigger picture, where countless galaxies move through space with the same slow, harmonious rhythm, shaping a universe that feels vast yet deeply connected at every level. If you could continue drifting outward from the Milky Way, watching it shrink gently behind you into a soft spiral of light, you would soon notice that our galaxy is not floating alone in empty space. It belongs to a larger structure, a small, quiet gathering of more than 50 galaxies known as the local group. From far enough away, the Milky Way and Andromeda would appear as the two largest lanterns in this group, each glowing with its own swirl of stars, while the smaller dwarf galaxies flicker softly around them like distant candles. The local group itself moves through space as a single, loosely connected family. Its galaxies drift together, bound by gravity's gentle pull, creating a sense of cosmic neighborhood that feels surprisingly intimate given the immense distances involved. One of the most calming facts about this region is how slowly everything moves. Galaxies in the local group aren't racing or colliding in sudden bursts. Their motions unfold over billions of years. The Milky Way and Andromeda, for example, are approaching each other at a slow cosmic pace, but their meeting is still more than 4 billion years in the future. Even when they do touch, the encounter will be gradual, stretching across hundreds of millions of years. Most stars will never collide. Instead, they will drift past one another, their orbits gently rearranged as the two galaxies blend together. This kind of movement shows that, on the grandest scales imaginable, the universe prefers slow, measured changes rather than abrupt or violent ones. Another interesting truth is that the local group itself belongs to an even larger structure called the local sheet, a thin, flat arrangement of galaxies that all move in roughly the same direction. This shared motion gives the region a smooth, gentle flow, almost like a school of fish drifting through the ocean. The galaxies maintain their own shapes and distances, but they also participate in this broader rhythm, creating a pattern that stretches across millions of light years. Our galaxy's place in this structure is not random. It is shaped by the quiet gravitational forces that have guided galaxies since the universe first began to expand. As you look beyond the local sheet, the cosmic picture becomes even more breathtaking. Our galaxy is part of a huge cluster of galaxies known as the Virgo supercluster. This enormous region contains thousands of galaxies spread across a space so vast that even light, traveling at the fastest speed possible, takes tens of millions of years to cross it. And yet, despite its size, the Virgo supercluster is calm. Its galaxies drift within a stable, balanced pattern, each one following a path shaped by the combined gravity of the cluster. Clusters like this form the major building blocks of the cosmic web, adding depth and shape to the universe's grand design. One of the most fascinating facts about the cosmic web is how delicate and graceful it appears when mapped out. Instead of being a random scattering of galaxies, the universe is organized into long, thin filaments, vast threads of galaxies stretching across the darkness. These filaments connect galaxy clusters together, forming a network that looks almost like lace or the branching veins of a leaf. Between these threads lie enormous voids, quiet, empty regions containing very few galaxies at all. If you were to drift into one of these voids, you might feel the same calm you experience when standing in a wide, open field. The silence would deepen, the darkness would soften, and the nearest galaxy might be so far away that it appears as only the faintest flicker of light. The Milky Way sits along one of these filaments, gently pulled by the mass surrounding it. This positioning gives it a stable environment, with galaxies nearby but not too close. Our home galaxy moves along this filament the way a boat glides along a slow river. Its motion is shaped not only by gravity within the local group but also by the broader flow of matter across the cosmic web. This sense of belonging to something larger, being part of a structure that stretches across billions of light years, helps us understand our place in the universe with a perspective that is both humbling and comforting. Another calming truth is that the cosmic web evolves in quiet, gradual ways. The filaments form slowly as galaxies gather together under gravity's influence. Voids expand gently as matter moves away from them. Nothing in this process is rushed. The universe grows and changes at a pace so slow and steady that even entire civilizations would rise and fall without ever noticing a shift. This gradual evolution creates a sense of stability that extends far beyond the boundaries of any single galaxy. Even as stars are born and die, even as galaxies drift and merge, the larger structure remains peaceful and predictable. The cosmic web also carries faint traces of the universe's earliest moments. The arrangement of galaxies along its filaments reflects tiny ripples that existed in the young universe, just a fraction of a second after the Big Bang. These ripples shaped how matter gathered over time, guiding the formation of clusters, superclusters, and the vast web-like patterns we see today. The fact that something so ancient and subtle can influence the universe billions of years later adds a layer of quiet wonder to the structure around us. It suggests that the universe remembers its beginnings, carrying those memories forward in the arrangement of galaxies and the soft glow of starlight streaming across space. As you continue drifting outward in your imagination, the Milky Way becomes just one small point in this grand network. It no longer dominates the view. It simply blends into the tapestry of filaments and clusters, contributing its own gentle light to the larger whole. And yet, knowing where it fits brings a sense of comfort. Our galaxy is not lost or isolated. It is held in place by the quiet, steady forces that guide everything in the universe. It moves alongside its neighbors in a pattern that has been unfolding for billions of years and will continue for billions more. From this vantage point, the universe appears not as an empty void, but as a living structure filled with calm, repeating patterns. Light travels along its threads. Galaxies drift in its currents. Stars within those galaxies follow steady paths. And within one small corner of one spiral galaxy, our sun shines gently, giving warmth to a tiny world that has learned to look upward and wonder. And as your awareness softens into this wider cosmic picture, the next part of the journey begins to unfold. A quiet reflection on the peaceful, predictable universe that surrounds us, and the sense of rest we can find in knowing we are part of something so vast, steady, and beautifully calm. As we drift even farther out in our imagination, letting the Milky Way shrink into a soft swirl of light and the surrounding galaxies become tiny glimmers scattered across a dark canvas, a new feeling begins to settle in. It's the quiet awareness of just how vast the universe truly is. Not vast in a way that feels frightening or overwhelming, but vast in a way that invites you to breathe a little deeper. Out here, distance stretches gently in every direction. Space isn't crowded or chaotic. It isn't rushing or colliding in a noisy hurry. Instead, it unfolds calmly, like an endless horizon that gives everything room to move at its own slow pace. The universe teaches us, simply by existing, that stillness and expansion can happen together. One of the most soothing truths about the universe is that it's expanding slowly and steadily. This expansion isn't an explosion or a violent spreading. It's more like the universe is stretching in a soft, relaxed motion, the way a blanket expands slightly as you tug on all its corners at once. Galaxies drift apart not because they're fleeing something, but because space itself is quietly growing around them. Even though scientists measure this expansion using precise tools and complicated formulas, the experience of it, if you could feel it directly, would be peaceful. It's so gentle, so gradual, that life on Earth has gone on for billions of years without ever sensing a single ripple of that cosmic stretching. As you picture this expansion, it becomes easier to imagine the immense distances that make up the universe. The space between galaxies isn't measured in miles or even trillions of miles. It's measured in light years, the distance light can travel in a full year. And even light, the fastest thing we know, needs millions of years to cross from one galaxy to the next. These distances create a kind of silence, a soft and perfect stillness that fills the universe. Nothing crowds anything else. Nothing presses in. Everything has room to breathe. And strangely enough, those great distances bring a sense of comfort, because they show us that the universe is spacious enough to allow stability on every scale, from the drifting of galaxies to the orbit of our small blue planet. Another comforting fact is how predictable the universe is on these large scales. Stars follow familiar cycles. Galaxies trace gentle arcs. Clusters drift according to gravity's steady pull. Even the cosmic web, with its filaments stretching across billions of light years, holds a structure that changes only slowly, like a pattern woven into a piece of fabric that never frays. This predictability offers a kind of reassurance. While life may feel rushed, unpredictable, or noisy at times, the universe itself moves in rhythms so calm and patient that they make even the longest human lifetimes seem like brief, quiet breaths. The universe also carries memories in the form of ancient light. Every star you see at night is showing you the past. The light that reaches your eyes tonight may have begun its journey hundreds or thousands of years ago. Light from distant galaxies began traveling long before human history even started. When you look at the night sky, you aren't just seeing stars, you're seeing moments preserved across time, carried faithfully through silence. This idea can feel gentle and grounding. It means that nothing truly disappears right away. Light continues moving forward, sharing stories across the darkness, reminding us of the quiet persistence that exists everywhere in the cosmos. As we imagine ourselves drifting in this calm, expanding universe, we start to sense how connected everything really is. Gravity quietly links stars to their clusters, clusters to their galaxies, and galaxies to the larger web that spans the cosmos. Even the empty spaces play a role, sculpting the paths that matter takes on its long journey. Every part of the universe, whether bright or dark, visible or hidden, contributes to this vast harmony. And our Milky Way, our home, is just one elegant thread in this unimaginable tapestry. It carries its own stars, its own patterns, its own soft glow, yet it remains part of something wider and quieter than we can fully comprehend. Another calming truth comes from recognizing that the universe is still young in a cosmic sense. Many stars have yet to form. Many galaxies have yet to collide and merge into new shapes. Much of the cosmic web is still unfolding. This means that the universe is not rushing toward an ending. It's building toward a future that stretches far beyond anything we could ever witness. Its stories continue, softly and patiently, one slow movement at a time. And somehow, knowing that the universe has such endurance, such steady momentum, can make our own uncertainties feel a little smaller, a little less heavy. What often surprises people is that the vast emptiness of the universe is not a lonely place. Space is quiet, it is still and open. But it is also full of light and motion and connection. Galaxies tug gently on each other. Stars send out steady warmth. Moons reflect the glow of their planets. Even in regions with few stars, light continues to travel, bridging enormous distances. If you think of the universe as a great, dark ocean, then the galaxies are like ships whose lanterns never go out, always shining softly into the night. This picture helps us understand that we are part of something immense, but not isolated. We belong to the same cosmic environment as everything else. And then, there's Earth, our tiny home, floating in a quiet arm of the Milky Way. When you zoom out far enough, the details of our world fade. The cities, the roads, the noise, the fast pace of everyday life. Everything reduces to a small point of blue light, drifting gently through the calm of space. And in that simplicity, there's peace. From that faraway view, no worry feels as sharp, no moment feels as heavy. Earth becomes a soft, beautiful reminder that life exists in the midst of this great cosmic stillness, supported by forces that have held steady for billions of years. Your place in all of this is small, but meaningful. The atoms in your body were forged in ancient stars that once glowed in the Milky Way. The calcium in your bones, the iron in your blood, the oxygen in your breath, these elements were created by stars that lived and died long before the sun was born. You carry the universe within you in the most literal sense. You are made of its quiet history, shaped by its rhythms, connected to its vast, unfolding story. When you look at the night sky, you're not looking at something foreign or distant. You're looking at your own origins, your own cosmic family, scattered across space in gentle light. As we come to the end of this journey, let yourself rest in the stillness of the universe. Feel the weight of the day loosen. Feel your breath deepen. Imagine the galaxies drifting calmly, the cosmic web stretching quietly in all directions, the Milky Way glowing softly like a familiar lantern in a dark and peaceful night. There is no rush out here. No pressure. No noise. Only the slow, patient unfolding of a universe that has been moving in harmony for billions of years. And if this quiet exploration has brought you even a small sense of comfort tonight, if it has helped your thoughts soften and your body relax, you're welcome to return anytime. For more calming journeys through the stars, the Earth, and the wonders of science, feel free to like this video and subscribe to the channel. Let these gentle stories keep you company whenever you need a moment of peace. Close your eyes now, let the universe hold the rest, and drift into a deep, restful sleep.